this computer. All right, you can start.
Okay. So as we know that machine learning has been the focus of the study since many years now, and it is a data hungry field where it gives the ability to the users to interpret and analyze complex patterns and structures in the data. But lately, federated learning has been the focus of attention of most of the researchers, and that is mainly because of its it gives privacy to the clients that are involved in terms of protecting their data so that it cannot be compromised. And this is done by the federated learning approach. Like, it doesn't involve sharing of the data with other clients or to a centralized server. It basically share weights that are encrypted that provides privacy a lot. So, for example, the examples of these can be like hospitals. If they are given a task, all the hospitals are given the task to collaborate with one another over a given task. But the information or the data they have is quite it needs privacy, and it follows some privacy preserving policies that they cannot share their data due to the regulations imposed on them. So federated learning will give them the opportunity to collaborate with one another while keeping their data localized, and they can share the model and improve on a given task and yield improved models accurately. So for our project, we are also we have made a simulator of federated learning a, uh, using a library that is already available on GitHub, that is Privacy FL, that provides all the privacy preserving features and simulation activities. But there have been some drawbacks in the application, and we in our study have improved and the simulator by adding few features and a graphical user interface to support users and like system designers that are not expert or not from the field or are not developers that can easily use. The graphical user interface that we have built is very friendly, very user friendly, and we have added more features. Like before, the privacy FL library could only support clients that were up to 3. When we changed it to 4, it usually used to crash. So we fixed that error in that library. Then secondly, we also added, I have given the feature to the users to select their own desired algorithm. We have added 2 more algorithms apart from logistic regression, that are perceptron and multi-perceptron. This gives user the ability to make decisions based on feasibility analysis, whether adding a client will affect the computation time or simulation time to match the real world scenarios that they are in. So I'll ask Cletus to demonstrate the simulator for us.
Okay, yeah, thank you very much. I'm going to share my screen now. Sharing my screen. So this is my screen. I'm going to start my IDE. Can you see my screen?
Yes, I can see.
Okay. So let me turn this off first. So yeah, basically we have, this is PyCharm environment from where the application was developed. Basically we have different structures or different sources, in the project. We have the agent class, we have the app main window, This is the GUI class that generates the graphical user interface. We have the client agent that actually simulates the number of clients you can have, in the federated learning. Then we have this config file. Yeah, this is one of the very important files in the project. The project actually picks or configures itself using these parameters: the number of clients, number of servers, iterations, verbosity, whether you want to see your log output. These are different configuration parameters, in the program. So yeah, what we have done basically is to build, just like Maria said, the project has some limitations. Number one, it is not that user friendly. So we came up with a graphical user interface. So the first thing you need to do to run the application is to call this run simulation program. So once you call this run simulation program from your command line, Python run simulation.py. So this gives you a graphical user interface that shows the various simulation parameters of the project, privacy parameters. Here we can see select machine learning algorithm. So we have added additional algorithms for users to select either a perceptron or a multi-layer perceptron. Here you can select you can actually specify the number of servers, but for this project, it defaults just to one server. Here we have number of clients, number of iterations, length per iteration, and and some other features that you wish to configure. So you start the simulation by clicking on Run Simulation, which I'm going to do now. So this is on logistic regression. I'm clicking on Run Simulation, so it runs for a few seconds. And let me also add that this project makes use of the MNIST data set. So as it is now, you have to change the data set from the back end. So a future project or a future implementation will be to have a way of selecting a different data set from the UI so that you can carry out the simulation. So we can see this is the output of the simulation. So for 10 iterations, we have this cloud client agent 2, client agent 1. This is the 10th iteration actually, from first iteration to the last one. And this gives us a summary of all the parameters. We can see this is the personal accuracy on final iteration. This is the federated accuracy on final iteration. And here we can also see whether a client was converged or it diverged or never converged at all. So we can also see this information at this point. So basically, this is what the application does. I can choose to select a different algorithm here and run the application. You can also save. As you change all this, you can also save the parameters, and it saves in the configuration file. So I can run this. I can decide to clear the initial solution and run and use the multi-layer perceptron to run the simulation as well. So we can see this is working fine. So some of the challenges that we're running into has been documented in the project. So we had challenges as regards the environment, setting up the environment and trying to use the different operating system. So we have documented all that in the project.
And we can also see that for multi-layer perceptron, we have an increased accuracy as compared to the logistic regression before. It's 0.99. Before it was 0.8.
Mm-hmm. Mm-hmm.
So we also plan to add new and more algorithms to our project in our future work.
Yes. So that is what we have. So I'm going to stop this now. Then I'm stopping the recording as well.